In this video, we're going to continue looking at zeros of polynomial functions, and specifically, we're going to look at the conjugate zeros theorem. We're going to start by just defining what the conjugate zeros theorem is, and then we're going to look at just one example. So this says if a function defines a polynomial having only real coefficients, and if they give a zero, meaning we've got a complex zero, the I means it's complex, then what we know is the conjugate of that will also be a zero. So first off, I have one little typo. That shouldn't say a 0 of x. That should say a 0 of f of x right there. But then note the only difference between this 0 and this 0 is that sign. That's what a conjugate is. So if you have, for example, let's say this 0 was 3 plus 4i, then we'd automatically know that 3 minus 4i is a 0. If it was given to you that, let's say, negative 2 minus I was a 0, then you'd also know that negative 2 plus I would be a 0. So that's what the conjugate zeros theorem says. So now that we have that basic understanding, let's look at this example. It says, find a polynomial function f of x of least degree that has only real coefficients and zeros of 3 and 2 plus I. Well, it says of least degree, okay? And so we don't know at this point if it's a quadratic, is it a cubic, is it a quartic, is it second, third, fourth degree, but I know that I have one 0, so it's first degree. I know that I have another 0, so it's second degree, and here, this is your complex 0 because it has the I. And what we just learned, that if 2 plus I is a 0, then also 2 minus I would be a 0 with that conjugate zeros theorem. So I have 1, 2, 3 zeros, so what we know is that this is going to be a cubic function. So if I have f of x, and that's equal to x minus a, x minus b, and x minus c, with a, b, and c being the zeros, we could make that 3, 0 our a, this could be our b, and this could be our c. We might also have a scalar up here, but this problem doesn't look like it's super specific about that. It just says find a polynomial function, so there could be more than one. And so what I'm going to do here is I'm going to do x minus a times x minus b times x minus c. And this is basically our function. Now we could do a little bit of simplification, like I could distribute the negative into each of those parentheses. In fact, let's do that real quick and see what we end up with. I have x minus 3 times x minus 2 minus I times x minus 2 plus I. And you, depending on what your teacher was looking for, you could maybe stop there. But for the sake of this video, I'm going to go and simplify it into standard form. I'm going to multiply these two trinomials together. So I'm just going to distribute this out just so we can get this in standard form. So first off, as I do this, I have x times x, which is x squared, x times negative 2, and x times I. Then I'll do distribute this negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is 4. And negative 2 times I would be negative 2i. I'm running out of colors, but I'm going to keep going. Negative I times x is negative ix. Negative I times negative 2 is positive 2i. And negative I times I is negative I squared. So we have all of this that I'm about to simplify. And don't forget we have x minus 3 right here. So let's do some simplification. So often, a lot of this stuff cancels out. So negative 2i and 2i will cancel. Let's see what else we got. I see negative ix and positive ix. That'll cancel. And it looks like we're now ready to combine like terms. So if I have my x minus 3, it looks like we have x squared minus 4x plus 4. And then hopefully what we remember from previous videos is that if I squared is negative 1. So if I have the opposite of negative 1, that minus I squared is really going to become plus 1. So now by combining like terms, we have this. And then lastly, if I wanted to, and this is the part that I'm probably not going to go through for this video, but if I wanted to distribute this binomial into this trinomial, what you get is you get this cubic polynomial. It would be x cubed minus 7x squared plus 17x minus 15. So we kind of did a lot of multiplication just to simplify this polynomial up here into the standard form down here, but really don't lose sight of our main goal for this. Our main piece of learning from this video is that if we're given one complex zero, you automatically know that it's going to have a kind of a pair, another one with the opposite sign. That is the conjugate zeros theorem.